Today, our topic is factoring out a GCF, and our objective is that we will be able to factor the GCF out of an expression. So first, let's start with what is a factor. A factor is something that divides evenly into something else. For example, 4 is a factor of 36 because 36 divided by 4 equals 9. Something like 7 would not be a factor of 36 because 36 divided by 7 is a decimal. What is the greatest common factor of a polynomial? It's numbers and or variables that divide evenly into every term of the polynomial. It has to go into all the terms there are. So if we want to determine the GCF of 5x cubed y squared plus 20x to the 6th y cubed minus 10x to the 4th y, the first thing we need to know is the greatest number that divides exactly into 15, 20, and negative 10. And that number would be 5. Then we want to find the greatest degree or exponent of x that fits into x cubed, x to the 6th, and x to the 4th, meaning this one has 3 x's multiplied, this one has 6 x's multiplied, and this one has 4 x's multiplied. We want to take as many as we can from all of them, but it has to be the same thing. Since this one only has 3, the most we can take from all of them is x cubed. Similarly with the y's, we have y squared, y cubed, and just a y, which means y to the 1st. Since our third term only has one y to take out, that's all we can take out from all of them. Put them together, and that's your GCF, which would be 5x cubed y. What is the GCF of 3a squared minus 12ab plus 9b squared? The greatest number that divides evenly into 3, negative 12, and 9 would be 3. Since none of them share the exact same variable, the first two have a, the second two have b, none of that, there's no letter that's in all 3 terms, there's no variable in the GCF, so our GCF is just 3. What about 5x to the 4th plus 8x cubed minus 2x squared? What number divides exactly into 5, 8, and negative 2? The only thing that can go into all of them is 1. What can we take out if we have an x to the 4th, x cubed, and x squared? The most we can take is x squared. Therefore, the GCF is 1x squared, or just x squared. What is the GCF of 7c squared minus 11c minus 14m? The only thing that goes into 7, negative 11, and negative 14 is 1, and they don't have any variable in common, so our GCF is just 1. Why don't you take a minute and see if you can determine the GCF for each of the following. Go ahead and pause your video now. Now see if your answers match mine. How'd you do? Now for our next step, we're going to look at how do you factor out the GCF of a polynomial. We already found the GCF for all of these on the front, so I'm going to rewrite them. GCF here was 5x cubed y. So taking out a GCF is like distributing but backwards. When you distribute, you have something out front and then your parentheses, and you distribute it to each term. If there's 3 terms inside the parentheses, you end up with a final answer that has 3 terms. So if we're starting with 3 terms, after we take the GCF out, we should still have 3 terms inside our parentheses. So we're going to start, when we distribute, we take the thing outside and we multiply it to the inside. Since we're going in reverse, we're going to want to divide it out. So I'm going to divide each term by the GCF. The GCF then becomes the number that would be out front if we were distributing. What's left in the parentheses is what we get when we divide. So 15 divided by 5 would be 3. X to the third over x to the third would cancel out. Y squared over y to the first. We had 2 y's. We're taking one of them out, so there would be one left. You're subtracting your exponents. Plus 20 divided by 5 is 4. We started with x to the 6th. We took out x cubed, so we're left with x cubed. We started with y cubed. We took out a y, so we're left with y squared. Minus 10 divided by 5 is 2. X to the 4th, we take out x cubed. We're left with just an x. And y over y would cancel out. So that's all. And that's it. To check your answer, you could distribute the 5xy back into all 3 terms and make sure you ended up with the original problem. Let's try another one. Here our GCF was 3, so we're going to divide each term by 3. Since our GCF is just a number, the variables aren't going to change, just the numbers are. So our GCF goes out front. 3 divided by 3 is 1, a squared. Negative 12 divided by 3 is negative 4, a b. Plus 9 divided by 3 is 3, b squared. You try this third one. Factor out the x squared. Pause the video and then check with mine. In our fourth example, the GCF is just 1, so we don't really have anything to factor out because distributing a 1 wouldn't change anything, so it would all just stay the same. Now let's look at a couple that are a little bit different. How about 28x to the 5th plus 14x cubed plus 7x squared? First, let's figure out the GCF. What goes into 28, 14, and 7? That would be 7. And what can we factor out from x to the 5th, x cubed, and x squared? That would be 7, or x squared. So our GCF is 7x squared. 7x squared goes out front. 28 divided by 7 is 4. X to the 5th, take out x squared, we'd have x cubed, plus 14 divided by 7 is 2. Had x cubed, took out x squared, we're left with an x. 7 divided by 7. A lot of you guys would say that this cancels and we have nothing left. But remember, this is like distributing. If we want 3 terms after we distribute, we have to have a third thing here to distribute it to. So we're going to have plus 7 divided by 7 is 1. So we have to have a 1 there to hold its place. For our last two examples, it doesn't always have to be a monomial that they have in common. It could be a binomial, meaning two things within one. This first term is an x times x plus 2, and then we have a 4 times x plus 2. They both have this x plus 2. That's their GCF. So if we take that out, take out the x plus 2, those are gone, we're left with x, plus these are gone, we're left with 4. Similarly here, if we take out the a plus 2b from each term, we're left with 2a, and a minus sign. We can't have nothing there, so it must be a 1. For your summary, write about how factoring out the GCF and the distributive property are related. That's all for today. We'll see you in class.